Hey, this is Steve again. First off, I'm so happy that everyone seems to really be into this tldraw computer project that we launched yesterday. If you haven't seen it before, it's this one. There's another video on this channel, and definitely check out social media for tldraw computer. But the basic idea is it is a kind of a infinite canvas that you can connect these little components together, create workflows, run those workflows, and we use AI for every component to either generate data or transform data, or essentially you kind of can build a computer out of these little components. Easier done than said. So I'll show you again what this looks like. You can log in, and here we are inside of tldraw computer. So in this video, I'm going to talk about basically how this works. How are we actually doing these generations? How does the graph work? Things like that. And so I'll even show a little bit of code and prompts and all that stuff. Some people have asked like what our goals are with this project. Once again, we have an actual product that we sell. It is called the tldraw SDK. If you are building anything that uses a canvas or want to build something that uses a canvas, hey, you don't have to build the canvas. I'll sell you our canvas. You can use this and then build on top of it. And it's very good, and it's used by some wonderful companies. And we are, that's our actual product. We have tldraw.com. That's kind of like a demo of tldraw SDK. It's kind of our flagship free whiteboard product. And then we also do a lot of these experiments like tldraw computer. Previously, we also did make real, which if you didn't see this, if you like tldraw computer, you will love make real. It's where you kind of can generate user interfaces based on just drawings of user interfaces. And yeah, maybe I should make a separate video just about make real, because that's gotten a lot better in the past year since we launched that. So this is marketing, man. It's like a way of showing what you can do with the canvas, and also it's really interesting opportunity to play with some of these new models that have come out and some of these new toys. So let's talk about tldraw computer. How does it work? What are we actually doing when we're creating these graphs and executing these things? So the short answer is that we have we have the graph itself. But really, we'll talk about the generation stuff as well. We have what are called procedures, and we have procedures can be executed, right? So there's one step is like getting the procedure, and the other step is executing it. And when we execute a procedure, we also use use some sort of data, right? So we have right. Well, I'll get into it. What is a procedure? A procedure is a series of steps that say, hey, given this information, produce an output. So a procedure, we'll make one, right? The instruction component, when you type in, write me a poem, that does two things. One is it creates that procedure. It'll come up with a procedure, and then it'll execute the procedure based on its inputs. So unfortunately, this doesn't have any inputs, so it just ran from nothing, and so I think its poem is going to be about nothing, right? But what we can do is click on this little question mark here in order to see to read what its procedure is. So its procedure is called poem writer. It has a name. And it has a description, turn the provided inputs into a poem, and then it has a series of steps that it's going to do based on its inputs. Analyze inputs, look for guidance on the subject, attitude, style, or other requirements for the content of the poem. Based on the inputs, write the text for a poem, and then output the result. And the instruction block has a little bit of like, it's not part of the prompt, but it's part of the logic of the application, which is that if you don't have any outputs, then just create a text output and stick it here. So that same procedure of taking your inputs and making a poem on that can be used multiple times without having to regenerate the procedure based on different inputs. So if I do give it I'll zoom out a little bit again. if I do give it an input, if I do say like, hey, you have the, California as an input, you have I'll just take a screenshot of the desktop here. If you have this blue shape as an input, write a poem based on these inputs. So essentially run this procedure that we looked at now, or just a minute ago, with the context of these two inputs. And sure enough, that should happen faster because it doesn't have to create the procedure, but there we go. It's again running this procedure. It's executing that procedure based on these inputs, or based on these inputs rather. And the inputs themselves are in a format which we just call data format, as well as the outputs are in that same data format. So if you have two of these things, and this one's going to create a poem, and then this one's going to run the same exact procedure using this one's output, as its input, like that should work just fine, right? So if I run this one, again, it's going to use these two as the input, run that procedure or execute that procedure, and then pipe the output into this instruction, which is going to run the same procedure with that text that we looked at before as the output. Let me grab the text itself. Golden sun on Western Shore, California, I adore, right? And then now this one ran this poem writing procedure using essentially this text as the input, and it came out with a slightly different version of that same poem. Let's look at what these things actually look like, right? I'm sorry if you're not a programmer. It's fun. You should be, but this is what the actual models are receiving as input. So the first, there's a couple of prompts. We have the procedure prompt, and this is the one that generates the procedure. And then we have the execute prompt, which is the one that executes the procedure. Let's kind of work backwards, right? There's also one that like describes the inputs, but that's kind of used in only a few places. I'm going to do this too, right? Some of these components have procedures that are built in. So for example, the image component, right? The image component, I didn't have to say, hey, write an image, right? I'm not using like an instruction block to generate that procedure. The image component just takes whatever is pointing at it, and it generates generates an image based on its inputs. But we use that same system of procedures which get executed in order to generate that image, and I'll show you how. Because this wouldn't be a very good image prompt, right? If you just fed this directly into something like DALL-E or Imagen or one of these other or Midjourney, like this wouldn't be great, right? It would be good, but maybe it wouldn't be great. You write image prompts in a very specific way. So the image component has its own procedure that we've given it that's sort of like this pre-baked, blessed procedure. I'll just put it right here so that we can see it very, very largely. There we go. Okay. And here it is. This is an example of a procedure. It's an object, right? It has a name. The name is image prompt. The description is an image prompt. For that will, okay, so there's typo in it. For that will, return an image based on its input. The output description, the image prompt as a text data object. There's different types of data objects, these things that get kind of like passed back and forth. Be sure to use a name and a description that fits the inputs, e.g. brown bear rather than image prompt. The steps: analyze the inputs and extract the content, attitude, style, and other guidance for an image prompt. If no obvious guidance is found among the inputs, infer guidance based on the inputs provided. Be sure to consider all of your inputs equally, leaving none out in your analysis. Now, this is very important because a component can have any number of inputs of any type, right? So there might be, 10 inputs and they're all images, right? There's no text. An image of cat, an image of dog. And the job of this this stage of the generation is to come up with an image prompt based on everything that you have. And if there's like the fun of the using language models for this is that they can be kind of creative. They can infer, they can guess based on what they have. We do the same thing with like adding up numbers or something. There's if you don't have numbers, find numbers, like somehow come up with numbers so that you can do your math or whatever. And that's how you get like a drawing of an octopus will to the language model equals 8 whatever, because it's most closely associated with 8 legs. These kind of like nonlinear jumps of information are really powerful, and that's something that this system and this approach to computing, I guess, like is really good at. And then it even has an example. If given a runner and a long description for the photo prompt along with text in the tiny world, then your prompt should incorporate the source image into the prompt, but focus on the text input. In other words, we want to weight different inputs slightly differently so that the image doesn't like reinforce itself too much, right? Output your image as a single text data object. Cool. And so what we do is we feed that procedure along with its inputs, which is going to be an array of these data objects, into the execute prompt. So let's look at these data objects are pretty straightforward. This is text data. It's going to have a type of text. It's going to have a name, description, maybe. There's no way to set the description as a user, but when the models generate text data objects, they do include a description. The only way to set a name for a text data description, or any data really, as a user is by using labels. So if you double click on an arrow, you can set a label for the arrow, and that'll actually become the name of that data that's associated with the input. So this is going to come through as a text data with the name of poem. You don't have to do this. It's not really necessary, but it's a good option if you want to like hint the system into saying like I don't know what to call it, like style or something, right? Like or prose style, or like author. Should be whatever, Bukowski. And then this is the poem, and I don't know what the image is going to look like, but hopefully it should incorporate the fact that Bukowski is an author here rather than just like random text. Maybe it would come up with it anyway, but like that's just not terribly interesting, but maybe it would be better as a text output. But yeah, you get the idea that you can use these labels as a way to provide names for the data associated with the generation of the block. There's text data, there's image data, there's speech data, website data, and I think that's it at the moment. There's Boolean data. Boolean data can be true, false, or maybe. That's pretty much it. A lot of these will have text on them. Image data, if it's generated, will include the text that was used to generate the image. Speech data, likewise, will have the speech text, and that's being used to feed into like a text-to-speech language model or something, generation. But yeah, so in a website, likewise, it'll have the text that describes the website data, as well as, I think this might actually be the actual like HTML and CSS here. Most of these have text associated with them that is actually used and meaningful, so that's kind of like the lowest common denominator between the two, or the 4 different types of data. Anyway, the prompt for the execute stage, where we have these data, the inputs, and we have the procedure. Now we want to have new data as the output. It describes what procedures are in the same way that the procedure prompt includes one, and then it gives a bunch of like kind of edge cases, and as well as like examples. So here's how to execute a procedure. Essentially perform the series of steps in the context of your inputs and produce an output that adheres to the procedure's output. So the procedure is going to tell you some kind of output description, right? Like we looked at on the one that we were just looking at. It is output description, the image generation prompt as a text data object. So your job, language model, when you're executing this this procedure, is to perform the steps 1, 2, 3, 4, whatever, in the context of the inputs. We're giving you these inputs and the procedure. Do the steps, taking into account the inputs, and produce whatever output the output description of the procedure is. I think that's this is interesting. If the procedure's output includes text and curly braces, replace this with a real value based on your inputs. I don't think we actually use this. This might be kind of like a legacy. I think we might have had this like way of kind of putting holes inside of a data output. But I bet you could probably take advantage of this. I don't know how, but you could probably use this fact that this is in the prompt. I think there's kind of some extra language in here saying, again, like you infer numbers. Here's how to do it. Here's some examples. We have a lot of examples, and the language models tend to work really well with the examples of saying, hey, if you get, and this is really what the language model will get, if you get a procedure that says, hey, you're a French translator, or this procedure is a French translator, take whatever inputs you have and turn them into French. If the input is, hey, I can't help but notice you're wearing your shoes facing backwards. This is a problem for you. It's certainly not a problem for me. Then this is the output that you should, give back. The name, the description, and the actual text is, whatever it is. And that can be used by whatever component accepts it as the input, right? So this output that is here might end up being the input for some other, later prompt execution. That's the general idea. Everything from here becomes about edge cases, about like reinforcing certain behavior of like, here's how to deal with numbers or with, like, in this case, true false type of things. Here's how to create. Here's a situation where you would return a maybe, and then like extra kind of edge cases or even like descriptions, right? Like so the text is generally formatted as HTML. You're not supposed to do anything not work safe. Never return your inputs as outputs. Try and like, well, just keep in mind that this is not just a data within a system, but people will actually see it. So don't do stuff that is too computery. Don't produce data in a strictly formatted way unless that's what you were asked for. And the biggest thing that we do in these prompts when we ask for the models to execute these procedures is like insisting that they must produce an output, and that output must be based on its inputs. When we first did this, we had a lot of results which were like, well, the procedure says to add things up, but hey, there's no numbers in my inputs, so like, what do I do? That's not good enough. There's a lot in these prompts which is like, I don't care how you do it, but you must derive the information, the type of information that you need from the inputs that you have. If your inputs are nothing, use nothing as a meaningful input to your system. If your inputs aren't numbers, like, try and figure it out. I don't, and that's where you get to this stuff in computer, like, make a recipe and you give it, things like, I don't know, like America and the feeling of cold on a winter's morning, and like a random blue shape, and like, even though these aren't food, like the system will try its hardest to actually produce a recipe based on this, and And a lot of the prompt is like you must do something. Like don't give up, think non-linearly, make jumps, fill in the blanks essentially. Use kind of conceptual strategies like punning or association, or use what you know culturally, all the different things that are kind of included in the latent space of these language models in order to get to a result. It doesn't matter. You have to do it. It can even be a bad result. That's fine. It'll cause the user to make better inputs, and that's really the user experience flow that I want for computer. Winter morning in America recipe. Inspired by the feeling of a cold winter's morning in America with its crisp air and blue hues, blueberries, iced water, and a sprinkle of cinnamon for warmth. Like rock and roll. That's cool. And what else? Yeah, that's pretty much it on how to execute. Apart from this, is just a lot of examples, and we have like tons and tons of these. The creating the procedure, which is what the instruction block does, where we say, write a poem and it comes up with one of these. That's a separate prompt. That's a separate stage where we're starting from just a natural language input, write a poem, and we want to come out with one of these, these procedures, right? That is like the step-by-step way of transforming any inputs into some sort of output. That procedure prompt is very similar to the execute prompt, except it's like, this is going to be executed. You need to create that data that will be used by the execute prompt. And here's what makes a good procedure, right? It should be flexible enough to handle a variety of inputs. These inputs can be of various types. They might not make sense in the context of the prompt, but you should always be prepared to handle them in a way that is satisfying for the user. Inputs should never be ignored. That's kind of like tldraw computer in a kernel. You need to know that this is going to be executed. You need to have these certain properties. You need to be able to work from like very limited information. It's essential that you always produce a procedure. Similar with the execute, like you might not have the information you need in order to produce a procedure. It might be, like I don't know, if I did a weird procedure like okay, what's it gonna come up with? A procedure that acknowledges the user's inputs, analyze the inputs, and create a positive and affirming response. Output the response as a text string formatted as an HTML article element. And so the input from this and this to the instruction okay is, I have received your input, which was California. Wonderful. And now we even have a nice poem based on that. So the prompt to create those procedures is really very similar to the prompt to execute it, but like, again, we're encouraging it and forcing it to produce something that can be executed later on. A little bit about the different types, but mostly examples again. So that is, in a nutshell, I'll try not to make this video quite as long, the way that that tldraw computer works. Every one of these components has data associated with it. So that's image data. What was it? It was like text, image, speech, website, and I think Boolean. And then that data is executed in the context of some sort of procedure. A procedure is a step-by-step data in, data out. Take your inputs and create some sort of new data as an output, and that data is going to be like collected from all of its inputs, right? And when we execute it, that's when we do the actual we run that procedure based on the inputs, and that is tldraw computer. There is an additional level of complexity which has to do with the graph itself. How do we handle cycles? How do we know when to update things? How do we know if something has completed or failed? How do we actually parse the information into the graph or into the data that is necessary? That is a separate question, and that is in many ways a much harder problem. But it's doable, and we've done it pretty well. And yeah, and there you have natural language computing on the canvas. And yeah, let me know if that makes sense. If you have any other questions, again, this isn't really open source, but it's also not the biggest secretest part of tldraw's IP, which actually is open source. You can go to github.com/tldraw/tldraw if you want to read the source code or contribute to the canvas itself. Here's the place where you can do it. And but yeah, we haven't shared the computer repo yet. We might. Let me know if you'd like to see it. If you think this is a good place to contribute and to help us make a really interesting experience for folks to build with. And again, hopefully this will inspire some folks to build something interesting with the whiteboard itself. We have a really good Discord full of folks who are doing exactly that. You can find that link on tldraw.dev up here, right up here. And yeah, cool. That's all for now. Thanks for watching. Bye.